Deep beneath the rugged landscapes of Nevada lies a geological secret millions of years in the making: supervolcanoes. These ancient giants, hidden in plain sight, have shaped the state's terrain and hold clues to Earth's fiery past. Unlike the explosive eruptions we imagine, Nevada's supervolcanoes are slow, silent architects, their calderas carved over eons. Let's journey into the heart of these geological marvels, unveiling the ancient calderas that define Nevada's volcanic legacy. Nevada is no stranger to dramatic geology. Its deserts, mountains, and basins tell a story of tectonic upheaval, but the supervolcanoes add a chapter of immense power. A supervolcano isn't just a bigger volcano, it's a system capable of erupting over 1,000 cubic kilometers of material, enough to blanket entire states in ash. In Nevada, these systems are tied to calderas, massive depressions formed when a volcano's magma chamber empties, causing the ground above to collapse. What makes Nevada's calderas unique is their slow, patient formation, a contrast to the cataclysmic eruptions of places like Yellowstone. The story begins over 30 million years ago, during the Oligocene epoch. North America's crust was stretching and thinning as tectonic plates shifted. In what is now Nevada, magma chambers swelled beneath the surface, fueled by heat from the Earth's mantle. These chambers didn't always erupt explosively. Instead, many released their energy gradually, through massive lava flows and ash deposits, forming calderas that spanned dozens of miles. These slow supervolcanoes reshaped the region, leaving behind a landscape of subtle clues. One of the most remarkable examples is the McDermitt Caldera, straddling the Nevada-Oregon border. Formed around 16 million years ago, this caldera stretches over 40 miles across. It's one of the largest in North America, yet its size went unrecognized for decades, hidden by erosion and time. The McDermitt Caldera didn't form in a single earth-shattering blast. Instead, it evolved through repeated eruptions, each one layering ash and lava, gradually hollowing out the crust. Today, it's a treasure trove for geologists, rich in minerals like lithium, a legacy of its volcanic past. Another giant lies in central Nevada, the Stillwater Caldera. Born around 25 million years ago, this caldera spans roughly 30 miles and is part of a chain of volcanic systems that swept across the state during the Miocene epoch. The Stillwater Caldera's eruptions were less about fiery explosions and more about relentless outpourings of molten rock. Over time, these flows built vast ignimbrites, sheets of welded volcanic ash that hardened into cliffs and plateaus. Hiking through this region, you'd be walking on the remnants of a supervolcano's slow fury. What sets Nevada's supervolcanoes apart is their connection to the region's unique geology. The Basin and Range province, where Nevada sits, is a land of stretching crust, where the Earth's surface is pulled apart, creating faults and basins. This extension thinned the crust, allowing magma to rise more easily, feeding the supervolcanoes. Unlike Yellowstone's hotspot-driven eruptions, Nevada's calderas formed in a dynamic, stretching landscape, their magma chambers fueled by tectonic stress. This slow stretching gave the volcanoes time to build massive calderas without the catastrophic bangs we associate with supervolcanoes. The evidence of these ancient giants is everywhere, if you know where to look. In the Black Rock Desert, volcanic rocks hint at eruptions from nearby calderas. The Toyabe Range holds tough, compressed volcanic ash from eruptions millions of years ago. Even Nevada's famous gold and silver deposits owe their existence to these supervolcanoes, as mineral-rich fluids rose through cracks in the cooling calderas. These landscapes aren't just beautiful, they're a geological archive. But how do scientists uncover these hidden calderas? It's detective work on a grand scale. Geologists study rock layers, mapping ash deposits and lava flows to piece together a caldera's boundaries. Radiometric dating pinpoints when eruptions occurred, while seismic imaging reveals magma chambers deep underground. In Nevada, where erosion has softened the caldera's edges, this work is like assembling a puzzle with half the pieces missing. Yet, each discovery, whether a layer of tuff or a mineral vein, adds to the story. Today, Nevada's supervolcanoes are dormant, their magma chambers long cooled. But their legacy endures. The calderas influence groundwater flow, shaping springs and wetlands. Their minerals drive Nevada's mining industry, powering modern technology. and their stark beauty draws adventurers to places like the Great Basin, where the past feels alive underfoot. While these giants no longer rumble, they remind us of Earth's restless nature. Could Nevada's supervolcanoes awaken? It's unlikely. The tectonic conditions that fueled them have shifted, and their magma sources have quieted. Modern monitoring, like seismic networks, keeps watch for any signs of activity, but the data suggests these calderas are relics of a bygone era. Still, studying them helps us understand active supervolcanoes elsewhere, like Yellowstone or Long Valley, preparing us for what Earth might have in store. Nevada's slow supervolcanoes are more than geological curiosities. They're a testament to the planet's deep time. Their calderas, etched into the desert, tell a story of patience, power, and transformation. From the McDermitt Caldera's lithium riches to the Stillwater Caldera's ancient flows, these silent giants have shaped Nevada's past and present. As we walk their landscapes, we're treading on the remnants of Earth's fiery heart, a reminder that even the quietest volcanoes leave an indelible mark.